Hello everyone, welcome back to the channel Code with AKJ. Today is day 14 of solving LeetCode 75 challenge. So today we'll be solving an interesting problem from sliding window technique, that is maximum average subarray 1, and we'll start with the brute force approach and work our way towards the optimal solution. So let's dive in. So the question says here, you are given an integer array nums consisting of n elements and an integer k. Find a contiguous subarray whose length is equal to k that has the maximum average value and return this value. Any answer with a calculation less than 10 power 5 will be accepted. So the problem is simple yet challenging. So given an integer array nums and an integer k, we need to find the contiguous subarray of length k that has the maximum average value. And we need to return this maximum average value with an error margin of less than 10 power minus 5. So given examples here, nums 112 minus 5 minus 6 50 and 3 and k value is 4. So in this nums array, the maximum average is the sum of these four integers. And as we know, the maximum average can be calculated using the formula sum of the numbers by number of numbers. So here sum of numbers 12 minus 5 minus 6 50 is 51, and divided by number of integers, that is 4, we'll get an answer as 12.75. Here we need to observe that we need to return the output in the form of double data type. So let's start with our brute force approach. The idea here is to calculate the average for every possible subarray of length k, and then we'll iterate through this array. We'll calculate the sum of every subarray of length k, and we'll keep track of maximum average. So let's understand with this given example. So here I've taken nums array and k value is 4. So in our brute force, since we need to calculate the maximum array for every possible subarray of length k, we'll use two for loops. And we also keep track of the maximum average by taking a variable max average, which would be initially int min. And since we are calculating the average for every length k, our first for loop will go till n minus k, and our second for loop will start from I till I plus k. So in this way, as I starts from index 0 and j starts from index I, and I goes from 0 to n minus k, and j goes from j to j plus k. So our first subarray of length k would be 1 to minus 6, and second subarray of length k would be 12 to 5. And in this way, using two for loops, we'll calculate the subarray of length k and its average, and for every subarray, we'll calculate average, and after calculating the average, we'll compare it with our max average and we'll update it. So this is our brute force approach. The time complexity of this approach would be O of n cross k, and space complexity would be O of 1. So let's move on to the code and let's submit. So let's try to code this brute force approach and let's see whether it gets accepted or not. So here we need to return the average value in the form of double data type. So we declare the variable in double data type. We'll take the maximum average value, which would be initially int min. We'll take the size of the array. We'll use two for loops where I starts from 0 till n minus k. So to calculate average, we need current sum. So we'll declare a variable current sum, which will calculate the sum of the current subarray. We'll use another for loop which starts from I till I plus k, since we need the subarray of length k, and we'll calculate the sum of this current subarray. So after calculating the sum, we'll calculate the average value of this current subarray sum. We'll declare the variable current average and we'll calculate it using current sum divided by k. And finally, we'll update our maximum average value by comparing it with current average. And after finishing our two for loops, we'll get our maximum average, and finally we'll return that maximum average. So let's run this code. So let's submit. As you can see, this brute force approach works, but it's not that efficient, especially for larger arrays. So before move on to the optimal solution, if you have made it this far and enjoying this explanation, Don't forget to like this video and subscribe to the channel if you haven't already. So now let's dive into the efficient solution. Now that we have seen the brute force approach, let's talk about a much more efficient method, that is the sliding window technique. So before jumping into the code, let me quickly explain what the sliding window technique is and how it helps us to solve this problem more efficiently. So the sliding window technique is a powerful optimization approach used for problems involving substring and subarrays. So here the key idea is, instead of recalculating everything for every new subarray, we'll maintain a window of fixed size. As the window slides one step forward, we'll add the new element that enters the window and we'll remove the old element that exits the window. So this allows us to efficiently update the sum or product or any computation for the current window in constant time, rather than recalculating everything from scratch. So now let's see how does it help in this problem. So in this problem, we need the maximum average of subarrays of size k. So here we got a fixed size and we need to find the average of subarrays. So based on these two conditions, we can see that this particular technique is applicable here. So using the sliding window technique, we first calculate the sum of the first window size, that is size of k, which is value 4. Then slide the window one element at a time. We'll subtract the first element of the current window, that is the exiting element, and we'll add the next element in the array, that is entering element. This way we'll maintain the sum of the current window in constant time, which drastically reduces the number of computations. So by doing this for entire array, we can efficiently find the maximum sum of all subarrays of size k. So dividing this maximum sum by k gives us the maximum average. So let's move on to the code and later on let's dry run with this example. So let's quickly write our optimal approach code. We'll take the size of the vector array. We'll take the window sum and max sum. So we'll calculate the sum of our first window, which is from 0 to k. So after calculating the sum of our first window, we'll update our max sum with our current window sum. And finally, we'll slide our window by removing the first element from our window and adding one new element in our window. So we'll start our iteration from k till n. So our first step would be to remove the old element, and this can be done by subtracting the window sum with nums of I minus k, and adding new element can be done by adding the window sum with nums of I. So this particular line of code will remove the old element from the current window, and this particular line of code will add a new element into our window sum. And finally, after getting our window sum, we'll update our max sum with our window sum. And finally, we'll get our max sum from the whole array. And since we need to return the average, we'll return max sum divided by k. So let's run this code. So again, let's submit. As you can see, this approach gives a successful submission. And here the time complexity is O of n, since we only traverse the array once, and space complexity is O of 1. So let's try to dry run with an example and let's analyze the time complexity and space complexity of both approaches we have discussed so far. So let's dry run our optimal approach with this given example. So initially our n value would be 6, which is the size of our nums array, and window sum would be 0 and max sum would be int min. So our first step would be to calculate the sum of first window, the sum of first 4 elements, that is 1 plus 12 minus 5 and minus 6, which is 13 minus 11, 2. So we'll update our window sum from 0 to 2. And max sum would be updated from int min to 2. So our second step here would be to slide our window and add elements to it and remove elements to it. So we'll first remove our old element. So here old element would be 1. So we'll remove 1 from this window and we'll add 50 inside this window. So removing the old element, that is 1 from the window, will reduce our window sum from 2 to 1, and add the new element inside our window will give us 1 plus 50, that is 51. So after iteration 1, we'll get our window sum with 50. Now let's move with our second iteration, that is I value 2. So for now our window contains 12, minus 5, minus 6 and 50. So the current window sum is 51, and now let's remove our old element and add a new element inside our window. So removing our old element will give us 51 minus 12, that is 39, and adding a new element would give us 39 plus 3, that is 42. So after iteration 2, our current window sum is 42. Now let's compare this with our maximum sum value, which is 51. So since 42 is less than 51, our maximum sum remains 51 itself. So since we have reached at the end of this given nums array, we'll stop our iteration, and here we have got our maximum sum value, which is 51. And finally we have finished our iteration from our nums array. We got our maximum sum, and since we need to return the average value, we'll divide this maximum sum by k, that is 4. So dividing 51 by 4 gives us 12.75. So this was the small dry run for this given nums array n and k value 4. So now let's compare the time complexity and space complexity of two approaches we have discussed. So in brute force approach, it was simple to implement but inefficient for larger arrays. The time complexity for this approach was O of n cross k, and space complexity was O of 1. And in our optimal approach, where we have used sliding window technique, it is optimized for performance, especially for larger inputs, and here the time complexity is O of n, as we have iterated the array only once, and space complexity is O of 1. So to summarize, we tackled the maximum average subarray 1 problem using two approaches, brute force and optimal approach. While the brute force method is simple to implement, the sliding window technique is the optimal solution with the O of n time complexity. So if you found this video helpful, don't forget to like, subscribe and share, and let me know in the comments which approach you prefer or if you have any questions. See you in the next video. Thank you.